Today's lab is to show you how to use the stress transformation equations shown here in the picture. We start with a stress block in our original coordinate system, as we see here on the upper left, and ask how would our components of stress change if we rotate the stress block at our same stress state by an angle of theta. The angle of theta is defined as a counterclockwise rotation from the original coordinate system to the deformed coordinate system. A clockwise rotation would be a negative angle theta. The relationship between the stress components in the rotated configuration and in the original configuration are simply described by the equation shown here at the bottom. So you see, all we need is basically the state sigma x, sigma y, and tau xy in the original state, and the rotation angle between the two coordinate systems. If we have that, then it's a straightforward equation just to plug in. Let's explore the equations on a simple example. Let's look at the 1D stress state shown on the left side, where that stress state is rotated as shown here. We want a stress block oriented traditionally with horizontal and vertical orientation. So I described the original state with a coordinate system x and y, here shown in green, and I need a coordinate system for my target system. That's what I want to call x prime and y prime. I'm looking first at the rotation angle. The rotation angle goes from the original x to the final x prime, which is in our situation a rotation that's counterclockwise. That means the theta value must be a positive number. Next, we substitute sigma y and tau xy at the same time, since both are simply 0 KSI. I keep them in the equation just to show you that in general those terms are present. So you see that there are only the first terms in all of the three equations that's non-zero. So our result simplifies to sigma x primes tan cosine squared, and theta we didn't give one, so let's just pick theta is 30 degrees. So all that remains are sigma x prime is 10 times cosine squared 30 degrees, sigma y is 10 times sine squared 30 degrees, and tau xy prime is minus 10 sine 30 degrees times cosine 30 degrees. I leave the numeric calculations to you as an exercise. Just plug it into the pocket calculator to get that, and you get the three values. The only thing to remember is to add the units, since we were sloppy above skipping the units. Never forget adding units to your results.